Okay, so this will serve as our substitute lecture for today's class. This is November 26th. A few announcements before we begin. The first announcement is no class tomorrow. There is another asynchronous class, and I posted that. That should be on Blackboard. The next one is for the next two classes. You'll have a substitute. So the first substitute will be Mr. Martin Curley, and then the next one will be your recitation teacher, who you all know is Chelsea Cologne. Okay, so with those announcements out of the way, we can begin our lecture. Let me just, all right. Let me start. So, today we're going to be talking about sequences. What is a sequence? Well, here's an example of a sequence. 1, 1, 2, 3, 5, 8. You should try to pause the video and see if you can't come up with whatever the next element of this sequence is. I'll give you a second. Okay, so the next element is 13. How do I get the next element? Well, I just add the preceding two elements. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. That's how I got 5. 5 plus 3 is 8. 8 plus 5 is 13. And then the next one will be 21. Okay, good. So that's a sequence. Here's another sequence. 2, 4, 6, 8, 10, 12, and so on and so forth. This is the sequence of even numbers. Here's another sequence. Let me think. Here's another sequence. 3, 6, 12, 24, 48. So how do I get the next element? I just multiply by 2. So each time I'm just doubling the preceding element. Okay. How do I get the next element here is I just add 2. Okay. So these sorts of sequences are called arithmetic. Arithmetic because they have a common difference. We'll go into more detail about this in a moment, but they have a common difference. So you're adding to get the next element. This one is going to be called a geometric sequence. Geometric sequence. Why geometric? Because you're multiplying. You're multiplying to get the next element. And this is neither. This is actually neither a arithmetic nor a geometric sequence. Okay? So, let's proceed. Let me give you some definitions. So definition, an arithmetic sequence is a sequence of the form a sub n equals a sub 1 plus d times n minus 1, where a sub n is the nth term. Don't worry if you don't understand this right off the bat. We're going to do some examples and it'll be very clear. A sub n is the nth term. A sub 1 is the first term. D is the common difference. Okay, I'm going to underline that, common difference. And I'm going to do just some examples. So here's an arithmetic sequence. 3, 6, 9, 12, 15, and so on and so forth. Here's another example. 7, 11, 15, 19, 23, and so on and so forth. Okay, let's focus on this second one. So this is the first term. This is the second term, the third term, the fourth term, the fifth term. Okay, what happens? What if I want to know the 100th term? Well, since I'm adding 3 with each subsequent term, then I'm going to have to add 3 99 times to get the 100th time. Why 99? Well, okay, let's do an example. So my first term, so here's n, and here's a sub n, and here's number of times I added d, which in this case is 3. Okay, so the first term is 7, and how many times did I add 3? Well, 0 times. I haven't added 3 yet. The second term is 11. How many times have I added 3? Oh, once. Third term is 15. How many times have I added 3 so far? Well, 1, 2 times. 2 times. Okay, one more. The fourth term is 19. So how many times did I add 3? Well, 3 times. Okay, 1, 2, 3. Okay, so hopefully it makes sense now. Let's go back to the definition. So a sub n will be a sub 1, so you start with your first term, and then you add d to it, the common difference. In this case it was 3, we're adding 3, n minus 1 times. Okay, so you're going to be adding d n minus 1 times, and hopefully it's clear why you do that. Okay, so what is the 100th term here? Let me make a new, let me make a new slide here. What's the 100th term here? Well, I know that a sub n is going to be a sub 1 plus d times n minus 1. So that means a sub n is going to be 7, my first term here is 7, plus d is 3, my common difference is 3, times n minus 1. And actually you could simplify this further if you wanted to. I'm not going to do that, but okay, so this is, so now I want to know what is a sub 100. I just plug in 100. So 7 plus 3 times 100 minus 1, which is 7 plus 3 times 99, which is 697. No, wait, is that right? No. Sorry, I made a mistake. So this will be 304. So that'll be the next. That'll be the 100th term in this sequence. And you could find, so what's the 101th term? Well, that's going to be 7 plus 3 times 101 minus 1, which is 307. And that makes sense. From here to here, you add 3 units. So that's a good sanity check. Okay, so that was an example of an arithmetic sequence. Let's go over a geometric sequence. Geometric sequences are very similar. So let me write it this way. Definition: a geometric sequence is a sequence of the form a sub n is a sub 1 times r to the n minus 1. Again, we have this n minus 1 term here. Why is that? Well, it's going to be for similar reasons as there's in the preceding example. Let me make a new, all right, so let's do an example. Here's an example. Let's use the example that I gave you before. 3, 6, 12, 24, 48. Okay. This is a sequence. And to find the next element in the sequence, I can use the formula. So a sub n will be a sub 1 times r to the n minus 1. Okay, so if I want to know the nth element of this sequence, what is it going to be? Well, my a sub 1, this is a sub 1, is 3 times, here I'm multiplying by 2, so the common ratio is 2 to the n minus 1. And that would be the answer. That would be the nth term of the sequence. And if you wanted to know What is a sub 6? That would be 3 times 2 to the 6 minus 1, which should be 96. Okay. All right. So let's go back here, and I'm going to tell you what all these terms mean. Sorry, I guess this doesn't look very good. Let me make this an actual equality symbol. This is a sub 1. So where a sub n is the nth term, just as before, a sub 1 is the first term, and r is the common ratio. Not the common difference, but the common ratio. Okay. And why is there an n minus 1 here? Well, if you look at this example, it's for the same reason. How many times did I multiply by 2 in the first term? Well, 0 times, right? How many times did I multiply by 2 when I got to 6? Well, once. So this is the second element. I've multiplied by 2 once. At the third element, I'll have multiplied by 2 twice. At the fourth element, I'll have multiplied by 2 3 times, and so on and so forth. So that's where this n minus 1 comes from. Okay? That's why we always do n minus 1. Okay, so you are responsible to know all of these formulas, both of these formulas, I should say. I don't think they're particularly difficult. Once you've had practice working with them, they'll be second nature. Okay? All right, so let's work with sequences. Find the first 5 terms of the sequence. Okay. So let's start with 1. Or A, number A. So I want to find the first 5 terms of this sequence. Well, the first term will be a sub 1 is 2 times 1 plus 1, which is 3. A sub 2 will be 2 times 2 plus 1, which is 5. A sub 3 will be 2 times 3 plus 1, which is 7. And you can just keep going this way. There's a clear pattern here, so let's just take advantage of that. So a sub 4 will be 9, and a sub 5 will be 11. Okay. Let's do another one. Let's do number B. B, to find the nth term of the sequence. So a sub 1 will be 2 to the 1 plus 1, which is 3. A sub 2 will be 2 squared plus 1, which is 5. Okay. Looks like it's going to be this one, right? A sub 3 is 2 cubed plus 1, which is 9. So it's already different. A sub 4 is 2 to the 4th plus 1. 2 to the 4th is 2, 4, 8, 16 plus 1, which is 17. And 2 to the 5 plus 1 will be 33. Okay. So that's how you find the nth term of the sequence. These examples, we won't go over them. It's the same principle. Just plug in whatever term you want. Just plug in for n for all of these values. Okay. All right, let's move on to the next question. Given the first 5 terms below, write down the general term of the sequence. Okay, well, let's see. This is, what's the pattern? Well, I'm adding by 3, both here and here and here. So in general, it looks like I'm going to be adding by 3. So this is an arithmetic sequence. And I know that an arithmetic sequence is of the form a sub n is a sub 1 plus d times n minus 1. My a sub n then is a sub 1 is 5 plus, what's the common difference? 3 times n minus 1. Okay. Here, okay, this is e to the 4th, e to the 5th, e to the 6th, e to the 7th, e to the 8th. We talked about e a little bit. It's not important for this question that we're using the number e, but let's just go with it. Let me make this a little smaller. Okay. So this would be the answer. So for B, let's see. My first term is e to the 4th, and then I multiply by e each time. See that? I'm multiplying by e to get to the next element. So this is a geometric sequence, And we know that geometric sequences are of the form a sub n is equal to a sub 1 times r to the n minus 1. What's my common ratio? It's e. What's my first term? E to the fourth. So a sub n is e to the fourth times e to the n minus 1. This is a much more abstract question. Maybe I'll give you a simpler one in just a moment. But this would be the answer. Okay. These next few I'm going to skip just for now. We'll come back to them in a moment. Okay. Which of the following sequences is arithmetic? If they are arithmetic, write down the common difference. Okay, let's see. So from minus 17 to minus 8, I actually add 9. And then from minus 8 to 1, I add 9. From 1 to 10, I add 9. And from 10 to 19, I add 9. So this is an arithmetic sequence. I'm adding each time by a constant number. So this is an arithmetic sequence. So A is arithmetic. Okay? And the common ratio, where r is equal to 9. Okay? B. Let me erase this stuff here. How much am I? Okay, what am I doing here? Here I'm adding 4. And then from here to here, I'm adding 8. And from here to here, I'm adding 16. So since I'm not adding by the same number every time to get the next element, this is not arithmetic. In fact, you can see that this is geometric. You're multiplying by 2 each time. Okay? So, no, not arithmetic. C, let's see, what am I doing here? From 50 to 47, I subtract 3. From 47 to 44, I subtract 3, and so on and so forth. So I'm just subtracting 3 each time. Well, okay, I'm subtracting 3, but that's the same as adding by negative 3. Okay, so C is arithmetic, and I'm adding, oops, why did I write R? It should be D. So D should be minus 3. Okay. Now those are the answers. So let's go back here for just a moment. You can see that it doesn't really look like, let's do D for example. It doesn't really look like I'm adding anything to get from, or let's do C. It doesn't really look like I'm adding anything to get from here to here, and it doesn't really look like so let me give you let me just do it out. So C is 5 over 1, then 5 over 3, then 5 over 9, and then 5 over 27. So it doesn't look like I'm adding anything. It looks like I'm multiplying by 1/3. Okay? If you notice, you're multiplying by 1/3 for each term here. So that's going to be, so this is a geometric sequence. A sub n will be 5 over 1, or just 5, times r, what's my r? 1/3 to the n minus 1. That's going to be the general term of the sequence. Okay, okay, good. So let's keep going. Let me do one more here. Let me do this one. So my sequence goes minus 4 over 3, minus 11 over 7, minus 30 over 11, and so on and so forth. So this doesn't look like there's any pattern. I'm not multiplying by anything. I'm not adding anything. So what's going on here? Well, if I just isolate, if I just look at the top row by itself and the bottom row by itself, I actually begin to notice the pattern. For the top row, you just, let's see, from here to here, from 4 to 11. Oh, actually, no, there's a mistake on this question. I think there's a mistake here. Yes, actually, I wasn't supposed to go over this one. I apologize. So forget that question. Okay, let's keep going. So next, I'm going to define factorial. So what is factorial? Factorial, definition, n factorial is equal to n times n minus 1 times n minus 2 times ... 3 times 2 times 1. It's a very simple definition. Note n factorial represents the number of ways to arrange n objects. Okay, so n factorial represents the number of ways to arrange n objects. So for instance, how many ways can I arrange 3 objects? A, B, and C are my objects. How many ways can I arrange them? Well, let's just do it out. A, B, C is one arrangement. A, C, B is another. I'm just going to do this. B, C, A, B, A, C, and C, A, B, and C, B, A. So these are 6 arrangements. And if you'll notice, 3 factorial is 3 times 2 times 1 is 6. So that works. Okay. How many ways can I arrange 4 objects? Well, to answer that, you would just do 4 factorial. 4 times 3 times 2 times 1 is, let's see, 24. Okay. How many ways can I arrange 1 object? Well, that's just going to be 1. Okay. An interesting question, and it'll come up later on in the lecture and in your subsequent classes, is 0 factorial. What is 0 factorial? Well, how many ways can I arrange 0 objects? You don't see it, but, you know, in front of me there's nothing. How many ways can I arrange nothing? A lot of you might be inclined to say 0 ways, but actually there's 1 arrangement of 0 objects. So in fact, 0 factorial is 1. And this can be proven. I'm not going to prove it to you, but it is a fact that 0 factorial happens to be 1 instead of 0. So just be careful of that. And actually, it's an important fact that you need to know. Okay, so let's do one more question. Let me erase this here. Let's do number C. So C says, compute the following. 7 factorial over 5 factorial. Well, what is that? That's 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 5 times 4 times 3 times 2 times 1. I can make some cancellations, and I'm left with 7 times 6, okay, which is 42. Okay. All right, good. So that's going to conclude the first part of the lecture. We'll continue on into the second part, and we'll learn about summation notation.